The quadratic formula is a shortcut. It's the answer for completing the square. Completing the square is why the quadratic formula works. To use the quadratic formula, everything on one side, 0 on the other. Pick A, B, and C and plug them in. So let's use it. Let's use the quadratic formula to solve 2x squared minus 3x equals 5. Don't go pooling A, B, and C yet. You can't do that until everything is on one side, 0 on the other. So now we can expand our everything on one side, 0 on the other rule. Everything on one side, 0 on the other. Factor and solve or use the quadratic formula. So how do we get everything on one side and 0 on the other? 2x squared minus 3x minus 5 equals 0. A is 2, B is -3, C is -5. You got to get everything on one side with 0 on the other before you take your A, B, and C, because that's how you're going to make sure that you have the right sign, positive or negative. Once we have A, B, and C, we write down the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All over, not just the radical over. Plug things in. -b means the opposite of whatever b is. In this case, b itself is negative. Plus or minus the square root. Again, b is -3, so that whole thing gets squared. Minus 4 times a is 2 times c is -5. All over 2a. A is 2, 2 times 2. X equals the opposite of -3 is +3. Plus or minus -3 squared is +9. Negative times negative is going to be positive. 4 times 2 is 8 times 5 is 40. All over 2 times 2 is 4. This is 3 plus or minus the square root of 49. All over 4. That is 3 plus or minus 7 all over 4. Keep going. This is two things. 3 plus 7 over 4 or 3 minus 7 over 4. X equals 3 plus 7 over 4. X equals 3 minus 7 over 4. X equals 10 over 4, or X equals -4 over 4. Got to be careful with the negatives. Reduce. X equals +5/2. Negative over positive is negative. 4 over 4 is 1, or X equals -1. +5/2, -1. Since we got rational answers that didn't involve a square root in the answer or an I in the answer, That means we could have factored this one. Factoring would have worked, and we would have also gotten 5/2 and -1. We did the same problem. 2x squared minus 3x equals 5. Everything on one side, 0 on the other. Factor and solve. Airplane method, a 2x squared expresses as a 2x and a 2x. -5 times +2, that's -10. Numbers that multiply to -10 and add to -5. Or sorry, add to -3. I was going to say that's not going to work. Add to -3. That's going to be -5 and +2. Airplane method finishes off by dividing where we can. So 2x minus 5 times x plus 1 equals 0. X equals +5/2. X equals -1. But not all things factor. And since not all things factor, the quadratic formula exists to help us shortcut the completing the square. Let's solve this one. X times x minus 6 equals 3. We can't factor straight off because it's not equal to 0. So let's get everything on one side, 0 on the other. X squared minus 6x equals 3. X squared minus 6x minus 3 equals 0. We couldn't factor this if we tried. So quadratic formula, A is 1, B is -6, C is -3. X equals -b plus or minus the square root, b squared minus 4ac, all over 2a. X equals the opposite of -6 plus or minus the square root of -6 squared minus 4 times 1 times -3, all over 2 times 1. Just plugging in A, B, and C. The opposite of -6 is +6. Plus or minus the square root of all. -6 squared is +36. Negative times negative is going to be positive. 4 times 1 is 4 times 3 is 12, all over 2. X equals 6 plus or minus the square root of 48, all over 2. Let me write this up top. Give myself more room to work. X equals 6 plus or minus the square root of 48, all over 2. Let's get this answer in a nice acceptable form. So we split up 6 over 2 plus or minus radical 48 over 2. 6 over 2 is 3. 48, that's 16 times 3. A 16 underneath is a 4 on the outside. 4 over 2 is 2. X equals 3 plus or minus 2 radical 3. That's our answer. Let's say a ball is thrown upwards from an initial height of 3 feet. With an initial velocity upward of 27 feet per second. Wouldn't it be horrible if you had to make an equation given this information? This is not a physics class, so I'm not going to make you come up with the equation here. But we'll be given, this is represented by h equals 3 plus 27t minus 16t squared, where h is the height after t seconds. Find all t where height is 13 feet. This is what we're going to do now. And the good news is all that crap at the top, we don't need it to solve this. We can do it all with just this. That equation comes from that information I just erased. You'll never be asked to create this equation in this class, though. We're going to find all t where the height is 13 feet. So we're going to set h, the height, equal to 13, and we're going to solve for t. We're going to use the quadratic formula. We sure are. And we'll find all the t where the height is 13 feet. Let me get everything on one side, 0 on the other. And so I'm going to add the 16t over here. I'm going to subtract the 27t, and I'm going to subtract the 3, and I'm going to do that from both sides. So this is going to give me 16t squared minus 27t, 13 minus 3 is positive 10 plus 10 equals 0. I don't have any common factors I can factor out, so I'm going to use the quadratic formula with a equals positive 16 and b equals negative 27 and c equals positive 10. This is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over what? All over 2a. Now I just left blanks. I'm going to go through and put in my numbers. Negative 27 is b. A is positive 16. C is 10. A is positive 16. I'm going to use a calculator. Shocking, right? Opposite of negative 27 is positive 27, plus or minus the square root. 27 squared, 27 times 27 is 729. This is just going to be negative. Negative times positive is negative. 4 times 16 times 10 is 640 all over 32. X equals 27 plus or minus the square root of 729 minus 640 is 89 all over 32. I'm going to write this out as its two answers up top. X equals 27 plus radical 89 over 32. X equals 27 minus radical 89 all over 32. The square root of 89 is 9.43 about. I'm rounding. But if we continue to do the work, add, then divide, subtract, then divide. And we round again, and these were X's, but they should have been what? They should have been T, because T is what we're solving for. We're going to get 1.14 and 0.0.0 0.55, and these are in seconds. We don't get negative time, so both of these work. How does that make sense? How are we at a height of 13 feet twice? What comes up must come down. So I throw it straight up in the air, and 0.55 seconds, it hits 12 feet or 13 feet. It keeps going up. And then at 1.14 seconds coming back down, I hit 13 feet again. Specifically, I'd like to talk about this part right here. The b squared minus 4ac, the thing under the square root. This has a special name. It's called the discriminant. The discriminant is b squared minus 4ac. And I don't know if this is why it's called the discriminant, but it helps us discriminate the number of solutions we're going to get. I don't even know if I'm using that word right. But the discriminant tells us how many solutions of what type we're going to get. And that could be useful in graphing applications in future chapters. But for now, let's look for the discriminant in some problems and what it'll tell us. Imagine if it was 0. If we had 0 under the square root. Well, the square root of 0 is 0. Plus or minus 0 would just give us one answer. In fact, that answer would be negative b over 2a, but one single real rational answer. One real. And it will also be rational. What if it's negative underneath? What if we get the square root of a negative? Well, the square root of a negative number is going to involve I. It won't be a real answer. But we'll be adding that thing that involves I. We'll be subtracting that thing that involves I. If the discriminant is negative, we're going to get two non-real answers. What if it's positive? If the discriminant is positive, then we're going to get the square root of something. We'll have two real answers. We could even get a little bit more detailed. If it's a positive perfect square, that means the radical will even go away. That means that they will be rational. And if it's positive and not a perfect square, positive and something else, that means the radical won't go away. The radical won't go away. And they would be irrational. Two real and irrational numbers. So that's what the discriminant can tell us. Now, let's say we have 5x squared minus 3x plus 1 equals 0. If we wanted to, without solving this, find how many solutions and of what type, we would find the discriminant, b squared minus 4ac. And here a would be 5, b would be negative 3, c would be positive 1. So this is negative 3 squared minus 4 times 5 times 1. That's positive 9 minus 9. No, not minus 9. What's wrong with me? That's 4 plus 5. 4 times 5 minus 20. So negative 11. Having a discriminant of a negative number means that when we use the quadratic formula, there will be a negative under the square root. That means we're going to get two non-real solutions. Two solutions that will involve I. Let's do another. Two x squared equals 3 minus 6x. Well, before we can find a, b, and c, we've got to get everything on one side and 0 on the other. So plus 6x minus 3 equals 0. A would be positive 2, B would be positive 6, C would be negative 3. So B squared minus 4AC would be 6 squared minus 4 times 2 times negative 3. 36 plus 24 gives us positive 60. Having a positive 60 under the square root of the quadratic formula would give us 2 real answers. And since the 60 is not a perfect square, the radical would not go away. So they would be real and irrational solutions. Finally, if we had 4x squared plus 12x equals negative 9, again, get everything on one side, 0 on the other, before, so plus 9. Before we can pick our A, B, C. A is positive 4, B is positive 12, C is positive 9. B squared minus 4AC would be 12 squared minus 4 times 9. That's going to be 144 minus 16 times 9 works out to 144 as well. The discriminant is 0. 0 underneath the radical in the quadratic equation means instead of 2 solutions, we're just going to have 1 solution. It's going to be real. The radical is going to be gone, so it's going to be rational. In fact, it's going to be negative b over 2a. Negative 12 over 2 times 4, negative 12 over 8. It's actually going to be negative 3/2. But we don't want the answer. We just want the discriminant and what it tells us. We're going to solve this by using the quadratic formula. And we see that it is not given in a form where we can apply it directly. It's not like we can plug in 10, 2, and 5. But we do need to distribute to get rid of the parentheses. (10x times x is 10x squared minus 10x times 2 is 20x equals 5. Get everything on one side, 0 on the other. So subtract the 5. And we can simplify this a little more by dividing both sides by 5. That keeps us with a 0 on the right. But here we would have each of these divided by 5. 10 divided by 5 gives us 2x squared. Minus 20 divided by 5 gives us 4x. Minus 5 divided by 5 gives us 1. So A is positive 2. B is negative 4. C is negative 1. We're going to use the quadratic formula. which is negative b plus or minus the square root of b squared minus 4ac all over 2a. We're solving for x. This is x. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Put parentheses in. Now let me put the numbers in. B is negative 4. B is negative 4. A is positive 2. C is negative 1. A is positive 2. So this is all over 2 times 2. That's all over 4. The opposite of negative 4 is positive 4, plus or minus the square root of negative 4 squared is positive 16. Negative times negative is positive. 4 times 2 is 8. Times 1 is 8. Underneath the square root, 16 plus 8 is 24. We can simplify radical 24. It has a perfect square factor of 4. 4 plus or minus, this is 4 times 6 under the square root, all over 4. I need more room. Let me rewrite what we have. 4 plus or minus 4 times 6 under the square root, all over 4. 4 plus or minus, that's the square root of 4 times the square root of 6. Putting a lot of extra steps in, I am, because I want to make sure you can follow what I'm doing. Plus or minus 2 radical 6 all over 4, which can be split 4 over 4 plus or minus 2 radical 6 over 4. Four over 4 is 1. 2 over 4 is 1/2. Radical 6 over 2. And this is 2 answers. 1 plus radical 6 over 2. 1 minus radical 6 over 2. 1 plus or minus radical 6 over 2. Speaking of the quadratic formula, if we had negative 4x squared plus 2x plus 1 equals 0. And we wanted to find the discriminant. That's the part that's under the square root. That's just the b squared minus 4ac. We could use the discriminant to tell us how many and what type of answers we would expect in the full problem. This is in correct form. This is in the correct form. It is correct. A is negative 4. B is positive 2, and C is positive 1. B squared minus 4ac would be 2 squared minus 4 times negative 4 times positive 1. This would be 4 plus 16. This would be positive 20. Since it's not negative, it's not going to be complex solutions. And since it's not a perfect square, we're not going to be able to get rational answers. Since b squared minus 4ac, since the portion of the quadratic formula that's under the square root, since the discriminant is a positive, non-perfect square number, we won't be able to get rid of the radical. There'll always be a 2 radical 5. In the quadratic formula. So we're expecting 2 irrational solutions. We have 10 times 2a minus 1 squared minus 19 times 2a minus 1 minus 15. Now in 1c, it had been a cube, a square, and we'd have had another 2a minus 1. We did that by factoring the 2a minus 1 out, but here, what if we just simplified it? What if we said, let u equal 2a minus 1? Then, instead of having the big long thing squared and the big long thing, and having to square it, multiply through, do whatever to simplify and factor, now we just have 10u squared minus 19u minus 15. So if we use the AC method, we would want numbers that multiply to negative 150 and add to negative 19. This is going to be negative 25 and positive 6. Multiplies to give negative 150, adds to give negative 19. So this is 10u squared minus 25u plus 6u minus 15. Group the first two. We can factor out a 5u. Leaves us with 2u minus 5. From the next two, we can factor out a positive 3. It leaves us with 2u minus 5. Where do we go from here? Well, that 2u minus 5 is common to both. So we factor out the 2u minus 5. We're left with 5u plus 3. Now, are we done at that point? No, our problem had to do with a's. U equals 2a minus 1. So I'm replacing u with 2a minus 1 in parentheses. Distribute 4a minus 2 minus 5, 10a minus 5 plus 3 gives 4a minus 7 times 10a minus 2. We are almost done, but we're not quite yet done. 4 and 7, nothing in common, nothing can come out. 10 and 2, something in common. Both of these have a factor of 2, so let's factor that 2 out. It's going to go all the way in front. 2 times 5a is 10a. 2 times negative 1 is 2. Now, if you want to see that better, you can flip around those two factors so that the 10a minus 2 is in front, and then these would end up flipped around. You could see the 2 right next to the 5a minus 1 does in fact give us 10a minus 2. Does not matter what order these two are in. So let's use this u substitution again. We have 6z to the 4th minus 13z squared minus 5. Here the substitution might not be obvious right away, but our problem is we have a 4th power, a square, and a constant. We haven't factored anything like that yet. But if this was 6u squared minus 13u minus 5, we'd be able to do that. So we're letting u be z squared, which means u squared is actually z to the 4th. Because if we square z squared, it gives us z to the 4th. So this substitution with u equals z squared works. And then we factor that, AC method. 6 times negative 5 is negative 30. We want it to add to negative 13. So this is numbers that multiply to negative 30. Add to negative 13. It's going to be negative 15 and positive 2. Negative 15u plus 2u minus 5. First two terms we can factor out. 3u. We're left with 2u minus 5. Here we're going to factor out just a plus, just the plus sign, positive 1, because we already have the 2u minus 5. 2u minus 5 is in common. We're left with the 3u plus 1. Now we're going to go back and make the substitution. U is z squared, so 2z squared minus 5. U is z squared, so 3z squared plus 1. Always remember to go back and make the substitution at the end when you use substitution to do the factoring. (12x to the 4th minus 11x squared plus 2 equals 0. Let's be very careful. We would like this to be 12u squared minus 11u plus 2 equals 0, so that it's in our general form for a quadratic. In order for this to be an appropriate substitution, u equals x squared. If we square u, we're squaring x squared, which would be x to the 4th, and yes, u squared is replacing x to the 4th. Valid substitution. We factor. Let's use the new method. 12u squared, so we'll throw in a 12u and a 12u. 12 times 2 is 24. The numbers that multiply to 24 and add to negative 11 are negative 8 and negative 3. Here we have a 4 in common. Here we have a 3 in common. So 3u minus 2 and 4u minus 1, giving us u equals positive 2/3, u equals positive 1/4. But u was x squared. So x squared equals 2/3. X squared equals 1/4. If we take square roots of both sides, x equals plus or minus radical 2/3. X equals plus or minus radical 1/4, which is plus or minus 1/2. Square root of 1 is 1, square root of 4 is 2. Here, we need to rationalize radical 2/3, which is radical 2 over radical 3. Rationalize with radical 3 over itself. Gives us radical 6 over 3. Let's just go ahead and say that we know that if we go through and check all 4 of these solutions, positive radical 6 over 3, negative radical 6 over 3, positive 1/2, negative 1/2. I am assuring you that if you check them, they all check. So maybe that's an exercise for you to try. Equations, quadratic in form. So we're basically going to do some more u substitutions. Except this time, instead of just using it to factor, we're going to use it to factor and solve. So in example 8, we have x plus 1 to the 2/3 minus x plus 1 to the 1/3 minus 2. We would really like this if this was just u squared minus u minus 2 equals 0. So I'm going to tell you, write it this way. U, if this is true, is x plus 1 to the 1/3. As long as u squared works out to this, when we square this, then it is a valid substitution. And if we were to square something to the 1/3 power, it would be to the 2/3 power. And sure enough, u squared was replacing x plus 1 to the 2/3 power. So let's factor this. Numbers that multiply to negative 2 and add to negative 1 are negative 2 and positive 1. So u equals positive 2 and u equals negative 1. Now replace back. U was x plus 1 to the 1/3 equals 2. X plus 1 to the 1/3 equals negative 1. How do we get rid of 1/3 powers? We write this over here. X plus 1 to the 1/3 equals 2. And x plus 1 to the 1/3 equals negative 1. Cube both sides. X plus 1 equals 2 cubed. X plus 1 equals 8. X plus 1 equals negative 1 cubed. X plus 1 equals negative 1. So x equals negative 2. X equals 7. Can we just be done there? Nope, we have to check them. So we're going to check x plus 1 to the 1/3 equals 2. We're going to check it twice. We're going to check it with x equals 7. We're going to check it with x equals negative 2. So 7 plus 1, 8 to the 1/3 equals 2. Negative 2 plus 1, negative 1 to the 1/3 equals 2. Cube root of 8 is 2, so that one checks. Cube root of, what'd I do? What did I do? What did I do? Oh, I didn't go back all the way to the original. That was my fault. Just ignore all that. I went to here, which was not the original. It was just a step in the program. The original was x plus 1 to the 2/3 minus x plus 1 to the 1/3 minus 2 equals 0. Okay, let's check. X equals 7 again. So 8 to the 2/3 minus 8 to the 1/3 minus 2 equals 0. Cube root of 8 is 2. So 2 squared minus 2 equals 0. 4 minus 2 equals 0. 4 minus 4. 0 equals 0. That one checks. So x equals 7 we're still good with. Now we'll try x equals negative 1. Or sorry, x equals negative 2. X equals negative 2. So negative 2 plus 1 to the 2/3 minus negative 2 plus 1 to the 1/3 minus 2 equals 0. Negative 2 plus 1 is negative 1. This was the part where I was missing some information on the screwed up page. Cube roots of negative 1 are negative 1. So negative 1 squared minus negative 1 to the 1st minus 2 equals 0. 1 minus negative 1 would be plus 1. Minus 2 equals 0. 2 minus 2 equals 0. 0 equals 0. So they both check. 7 and negative 2. Apologies for the derailment during that problem. Let's take a look at example 8b. And I promise I'll do better this time. 6x to the negative 2 plus x to the negative 1 equals 2. To help us see its quadratic in form, let's subtract the 2 over so we get 0 on the right. We would really like it if this was 6u squared plus u minus 2 equals 0. But in order for that to work, u is x to the negative 1, and let's check what that is squared. That would be x to the negative 2, and yes, u squared did replace x to the negative 2. So this is a valid u substitution. Let's factor. And let's use the new method. You can use the AC method, verify it works. I really love this new method. We need it to multiply to AC, which is 6 times -2, which is -12. We need it to add to B, which is +1. The numbers that multiply to -12 and add to +1 are +4 and -3. We have a 6u squared, so 6u and 6u is what we'll put in. We'll put in our +4, our -3. Here we have a factor of 2 in common that we can divide by. Here we have a factor of 3 in common that we can divide by. So this factors to 3u plus 2 and 2u minus 1, and that is correct. This gives us u equals -2/3, u equals +1/2. But we got to replace back. U was x to the -1st, so x to the -1st equals -2/3. X to the -1st equals +1/2. Let's raise both of these to the -1 power, because that's what will give us x to the +1st. It'll give us our x equals. -1 power is just reciprocal, so -3/2. 2/1, just x equals 2. And if we check in the original, 6x to the -2 plus x to the -1 equals 2. If we plug in -3/2, we're going to square and flip. Plus -3/2 to the -1. It's going to be -2/3 equals 2. 6/9 is 2/3. So this is -8/3 minus 2/3 equals 2. Did I do that right? Let me try this one more time. Six times -3/2 to the -2 plus -3/2 to the -1 equals 2. Both of these should check, so I'm sure I was doing something wrong. And that's what I was doing wrong. Let's just go back to this page. We're still good. Squaring a negative number becomes positive. +8/3 minus 2/3 is 6/3, which is 2. Remember I said it's important when we're squaring and we have negative inside? Yeah, that's why. We would have thrown that answer out and it was perfectly fine. If we check it with x equals 2, this would be 6 times 1/4 plus 1/2 equals 2. 2. 6/4 is 3/2 plus 1/2 is 4/2, which is 2. So both our answers do check. Let's solve by substitution. T plus 5 squared minus t plus 5 minus 12 equals 0. Well, notice the thing that's squared is here as well. If we call that x, if we say, well, we don't use x for substitution. What do we use for substitution? What do we use? U. If we say u is t plus 5, then this becomes u squared minus u minus 12 equals 0. And we can solve this. We can factor this. We need numbers that multiply to negative 12 and add to negative 1. These are negative 4 and positive 3. U minus 4, u plus 3 equals 0. That means u equals positive 4. That means u equals negative 3. But these aren't our answers. These are u's. This problem was about t's. And u equals t plus 5. So t plus 5 equals 4. T plus 5 equals negative 3. Subtract 5 from both sides, t equals negative 1. Subtract 5 from both sides, t equals negative 8. Let's do this again. Z to the 2/3 plus 2z to the 1/3 minus 3 equals 0. This time it's not so obvious, but if we let u be this z to the 1/3, that means u squared would be z to the 1/3 squared, which is z to the 2/3, and that's what we have here. So this is u squared plus 2u minus 3 equals 0. And again, we can solve this. We can factor this. We need numbers that multiply to negative 3, that add to positive 2. These numbers are positive 3 and negative 1. U minus 3, sorry, u plus 3. I was getting ahead of myself. U minus 1. Which means u plus 3 equals 0. U minus 1 equals 0. U equals negative 3, u equals positive 1. But we're not done. These are u's. U is z to the 1/3. Z to the 1/3 equals negative 3. Z to the 1/3 equals positive 1. How do we solve these? Cube both sides. Because cubing the 1/3 power cancels them out. 3 over 3 is 1. Negative 3 to the 3rd is negative 27. So z is negative 27. 1 to the 3rd is 1. Z is 1. Negative 27 and 1 would be the answers.